up Grace's presentation on yellow to green, optimizing school bus routes to reduce the carbon footprint of local high schools. It's my pleasure to introduce Grace Yan, who is a junior at Morgantown High School, okay? In West Virginia. She's been a bus rider since she was in kindergarten and is very passionate about the environment. These interests prompted her to do research on bus route optimization to help reduce the carbon footprint of school buses. She hopes to be able to raise awareness for air pollution and climate change with her work. She's very interested in the intersection between math and science. Grace Yan.
Good morning, everyone. Thanks so much for this opportunity to present my project, Yellow to Green, Optimizing School Bus Routes to Reduce the Carbon Footprint of Local High Schools. My name is Grace Yan. Is there a way to?
Go forward.
Yeah.
The big button in the middle.
It's not working.
Wonders of technology. This did work. Can you?
I can advance.
Well, let's see. No. So, yeah, you'll just, for the moment, tell him to advance.
All right, next slide, please. So I'm a junior at Morgantown High School, but as you can see, I've been a bus rider since kindergarten. I love being able to talk to my friends every morning and afternoon on bus rides. Next slide. But as I entered high school and started driving, I realized that our buses would take roundabout, inefficient routes to school. I like to consider myself an environmentally friendly person. Next slide, please. But I knew that these inefficiencies in the routes were causing increased greenhouse gas emissions into our atmosphere. I'm also from West Virginia, the U.S.'s second largest producer of coal and known for having problematic air quality and pollution in many areas. So I wanted to research ways to make our buses more environmentally friendly. The first thought would be to upgrade our buses to an all-electric fleet. But obviously, this is very expensive and is not feasible for most school districts. Next slide. I recently discovered, just this morning at breakfast, that President Biden has devoted over $1 billion to turning our school buses electric, which is amazing. But until that happens, I wanted to find a low-cost, practical solution that could be easily implemented. Next slide, please. I also recently got my driver's permit, which means Google Maps is my best friend. Google has created very in-depth routing algorithms that optimize for distance, time, traffic conditions, and more. So this gave me an idea. What if we could optimize our school bus routes to make them more environmentally friendly using Google Maps? To get started, I wanted to visualize what the full bus routes look like to see if they're really as inefficient as they felt from my perspective as a rider. I have to wake up every morning at 6 a.m., so maybe I was just too tired to realize that our buses were actually really optimized. So I went to my school's website where bus route information was posted and focused on my own high school since it encompassed the largest geographical area and over 3 times as many buses as other nearby schools. I manually plotted all 388 bus stops in this map you see here, and this was encompassed by the 30 morning buses at my school. I color-coded each of the routes, and looking at the data, one thing I noticed was that the routes seemed to be very Frankenstein, as if new stops were being added to old routes year after year. The objective of this study is to create an accessible, zero-cost solution to reduce the carbon footprint of school buses by optimizing school buses for decreased travel mileage. So the first step in my process was to extract the GPS coordinates of each bus stop from its address. I created a Python script that automatically extracted these coordinates and used them in this human-in-the-loop component, which allowed me to override any locations that couldn't be parsed by my code. I then fed these coordinates into an algorithm that interfaced with the Google Maps API, which is Google's library for their routing algorithms, and also what powers the Google Maps app on your phone. I fed these coordinates and was able to format them into Google Maps API query URLs, which I then queried Google to find the most optimized route. Next slide. Then my code outputs the optimized route as well as the calculated total travel distance and duration. I repeated this process for all 30 buses at my school across multiple days and averaged the results. So here's a case study that really shows the essence of my project. Our school buses start at our county's transportation center on the left, and of course end up at our school. The bus goes to the route. Okay, there's gonna be a lot of clicking, so just a warning. But it goes to the route, and as you can see here, the numbers, which are a little hard to see actually, the numbers show the pickup order. So our bus goes through this route in this little loop, down to the bottom bus stop. So it goes down here, down to the bottom, and then to school. And so here, again, on the left, we have the original route, which shows the bus starting from this stop, curving around and going down, and then finally to school. But what the optimization tells us is that if we instead start our buses at this stop and curve around and to school, we would be able to save 3 miles and 7 minutes for just this route. Here's another example bus route, where essentially flipping the pickup order can save us 4 miles and 6 minutes. Here, our buses still start at our transportation center and currently go to this stop, curve around to school in this big loop. But instead, if we take our buses to start from this stop and go this way directly to school, we would be able to save these distances and these times. Next slide, please. Here are the results for all 30 buses at my school. The yellow bars show the original route, while the green bars show the optimized ones. And the graphs show the total calculations for the distance and duration. Looking at this data, I saw that some of the routes were already pretty well optimized, but others could be greatly improved. So I conducted a paired t-test to compare the travel distance in miles of the original and optimized routes. Here are the results. I found that my optimization was able to significantly decrease the total distance of these routes. Thanks. This table shows the carbon emissions reduction of the top most optimized buses. It turns out that 15 of the 30 buses saved greater than a 0.5 kilogram reduction in carbon emissions. Next slide, please. Okay, thank you. I also conducted another paired t-test to compare the carbon emissions reduction of the original and optimized routes. And here, I was also able to show that my optimization significantly reduced the carbon emissions from these routes. So I found that for just my school, using these optimizations, we would be able to save 20 metric tons of carbon dioxide from being emitted into the atmosphere each year, which accounts for 5% of the total carbon emissions. And over the course of one school day, we would be able to save 76 miles in over 2 hours. Throughout the entire school year, this would account for over $10,000 in fuel cost savings. And keep in mind, this is just for one school. With these results, I decided to reach out to the Monongalia County Director of Transportation to present my findings. He was super excited about the idea and invited me to present at the County Board of Education. Thank you. At the County Board of Education meeting. The board said that this was something they would love to explore in the following years. This gave me the idea to reach out to more individuals in charge to see if this could be something we could implement on an institutional level. I reached out to senators in my district as well as those in the state's capital and presented my findings. One senator was very excited about how my optimizations would be able to save not only tax dollars, but also reduce greenhouse gas emissions. Another said that this was a model that should be considered in all 55 counties in the state, which is very exciting. But most importantly, these senators were kind enough to introduce me to those that ran the school bus systems in their area. And I was reached out by the State Director of Transportation. I was able to present my results and discuss the implementation of my optimization in our schools and state's buses. We even got a pilot study confirmed and approved for my county to test and will hopefully expand to other counties in the future. In fact, I've already started working with another county, Barber County in West Virginia, to help optimize their routes. The map shows all 1,022 stops of the 29 buses in Barber County. And I've already helped them optimize a couple of their routes. And we are going to discuss the implementation of some of these routes, and hopefully we'll be able to test them very soon. The final part of my project was an idea I had to expand the accessibility through visualization. I built a website called yellowtogreen.org that's a carbon emissions calculator and bus route optimizer. It takes in a list of bus stop coordinates or addresses and automatically optimizes them to find the best route. It prints out the total route length and the corresponding addresses, as well as the calculations in the carbon emission savings and distance savings for comparing the optimized and the original routes. Essentially, everything I did in this project was put onto this user-friendly website, and I have a quick demo for how it works. I'm not sure if I play it. Hey everyone, here's a quick demo of my website, Yellow to Green, that lets you automatically optimize school bus routes. It's pretty self-explanatory. All you need is your bus starting location, your bus stop addresses, and your final destination, or school. You hit plot points and wait for all the points to plot. Then you can click Optimize. Here it gives you all the results with the current and optimized route length and duration, new stop ordering, and the corresponding addresses, as well as the savings per year of carbon dioxide emissions and fuel cost, making this a quick and easy way to turn your school buses from yellow to green. All right, thank you. All right, in conclusion, from start to finish, visualization has played an important role in this project. From confirming the original idea to analyzing the optimization results, we found that school bus routes can be optimized to reduce the carbon emissions. Using my algorithm, my school could save 20 metric tons of carbon dioxide emissions and over $10,000 on fuel each year. To put this in perspective, there are over 24,000 public high schools in the US. And this was all done by an accessible, low-touch, zero-cost optimization algorithm. I'd like to end with some acknowledgements. Big thanks to Mr. Gibson, Dr. Yoon, Miss Rhonda, Miss Pat Hu, and my parents for all their help. Here are my references, and that concludes my presentation.
I think this this is a wonderful example, and her mom is actually here, so. This is exciting to see a student who has seen a problem and gone after a solution, found the solution, and found a really good way of visualizing how she's done it. So, questions?
Did you learn how the school, during your research, did you learn how they currently plan their stops? You mentioned a little bit earlier.
Oh, yeah. So I think when I talked with the director of transportation, the routes had just been there ever since our school had been created or started. But just like I said, year after year, if new students were coming from certain areas, they would just add stops to whatever route was the closest and what seemed like was the best idea. And so that was what created some of these Frankensteining of the routes and what caused these inefficiencies. I'm sure at one point these routes were really great, but over the years they had become less efficient. And so that's why I decided to target.
Have you looked into adding any more variables, such as changing a stop from one route to another, or trying to move the stop to see if putting it on a different around the corner might and add a small amount of walking time for the students might make it more efficient overall? So moving the waypoints as part of the
Yeah.
or moving them from route to route?
All right, great question. So actually, I do have a couple of limitations of the study that I wasn't able to consider. So I wasn't able to consider, of course, regrouping the bus stops because I wasn't able to present this project in a way that I thought would be easy to implement if I was going to propose that we change our bus routes entirely. I wanted to find a low effort change that would be able to be implemented, which is the first thing I was thinking about when doing this project. So I really wanted to focus on something that could be easy to do, low effort, that my transportation director would, easily agree to. So obviously, changing the routes, which would greatly reduce the emissions, and would also be able to consider taking out certain buses and reducing the number of buses, which would also help our greenhouse gas emissions. But another thing I wasn't able to consider was changing the parking locations of the buses. So if you look at the map, I don't know if we can go back to it, but the map showed that a lot of our buses started from the transportation center. And since the transportation center is our counties, it's kind of in a centralized location for all the counties, not just our school, or not all the schools in our county, not just my school. So I noticed that a lot of the bus routes were really far away from where they were being parked. And so if we could change where the buses were being parked, we'd be able to reduce the distance of the overall routes by pretty significantly.
First of all, I'm really surprised that this research can be done by high school students. This is
Thank you.
Great research. And actually, it's not a question, it is my comment. When you consider school bus optimization to reduce the air quality is great, but we also need to consider about potential crash risk, because we need to minimize the number of left turn events. Also, we need to minimize the crossing the street of the kids to minimize the crash.
Yeah.
Possibly, it will be your future research topic in order to consider to minimize the crash risk when you consider optimizing the school bus routes.
Yeah, so one big concern, especially for elementary students, is crossing the road to the buses, right? Because you don't want them to cross busy roads. But I'm a high schooler, and this is exactly why I wanted to optimize our high school routes, especially since they are a lot earlier in the morning and it might be dark out. But for my personal bus, to get off the bus and go to my neighborhood, I do have to cross the road, and it's not a big deal for me and the high schoolers, especially since I noticed that my route in particular in my house, you can go down the road and curve around, and so it is a big U-turn. But I noticed that the high schoolers at my neighborhood would always just get off early and cross the road instead of waiting for the extra 1 or 2 minutes for the bus to curve around and then for us to get off. So I think I realized that our high schoolers, at least, maybe the parents, but not ourselves, really cared about crossing the roads. Of course, this is a big concern for elementary students, but for us, it wasn't such a big deal.
Excellent. One more back here.
Yeah, hi. First of all, I have teenage daughters, and you make me proud, like mom. But your initial, and I'm Grace with Esri, but your initial, and I like your name too. You initially wanted to reduce GHG emissions, right?
Mm-hmm.
And then I think you got the ear of the state. Is there talk now of implementing not just optimized routes, but implementing electric buses and an electric fleet? Has that been talked about?
I haven't heard too much from who I've been talking with about changing to electric buses. I wanted something that we could do for zero cost, would not cost us any money. And obviously, having a grant to change from electric to electric buses would be a great help to reducing our greenhouse gas emissions. But this is an optimization that can be done on regular diesel-powered buses, but also electric buses. I originally thought that, electric buses would be great for the environment, and that they are, but they do release half the amount of carbon emissions. So it's not like they're releasing no emissions at all. And so this is still something that could be considered in electric buses as well.
Very good. Thank you very much.